everyone, my name is Braden Turpo, and today I'll be discussing a paper to be titled Moral Wounds Run Deep, Elevated Midbrain Functional Network Connectivity in PTSD. A moral injury may occur when a deeply held moral code has been violated. Moral injuries may result in PTSD symptom development, yet the neurocorrelates differentiating moral injury and PTSD stand to be revealed. Intrinsic connectivity networks may be a good place to start, since intrinsic connectivity networks like the default mode network have been revealed to be altered in PTSD, especially during self and memory-related processing functions mediated by the default mode network. Rarely integrated into the intrinsic connectivity networks, brainstem, midbrain, and cerebellar systems have been revealed to be altered in PTSD as well. And a recent paper by Turpo and colleagues revealed that a particular midbrain structure, the midbrain periaqueductal gray, shows stronger functional connectivity with the default mode network in PTSD. Here, we wanted to study the default mode network functional network connectivity in moral injury exposed samples with and without PTSD, with a particular focus on brainstem, midbrain, and cerebellar systems. We conducted an independent component analysis during a moral injury-related memory recall task. Since the task was a memory-related task, we expected to recruit the default mode network, which we hypothesized would have stronger midbrain functional network connectivity in participants with co-occurring moral injury and PTSD. In addition, we wanted to highlight the significant and yet under-investigated role brainstem, midbrain, and cerebellar systems have toward the intrinsic connectivity networks. We recruited 74 participants total, which included 18 moral injury exposed healthy controls and 56 participants with co-occurring moral injury and PTSD. Co-occurring moral injury and PTSD participants were sorted into two separate groups based on what occupational setting the moral injury had occurred in, either military and law enforcement related or civilian related, which included frontline healthcare workers and first responders. Prior to scanning, participants were asked to recall a neutral and a moral injury related memory, which were used to develop individualized scripts to be displayed to the participant audio-visually. Moral injury-related scripts always followed neutral scripts, and each script was broken into 8 separate sentences, which were presented in chronological order, sentence by sentence, serving to facilitate memory recall stepwise. We conducted an ICA using the GIF toolbox and generated 20 maximally anti-correlated independent components, each with a unique spatiotemporal pattern. Generally, sensory networks like the visual and auditory networks are identified, as well as intrinsic connectivity networks like the default mode network, since these networks are highly conserved across subjects. We selected the IC most similar to the default mode network and used the default mode network correlated IC, IC3, to look at functional network connectivity differences across the default mode network groupwise. As we would expect, the default mode network correlated IC included midline cortical regions primarily, namely the medial prefrontal cortex, the posterior cingulate cortex, and the precuneus. We revealed stronger periaqueductal gray and cerebellar lobule 9 functional network connectivity in participants with civilian-related PTSD as compared to moral injury-exposed healthy controls, as well as a trend towards stronger periaqueductal gray functional network connectivity in participants with military and law enforcement-related PTSD as compared to healthy controls. We also correlated functional network connectivity with clinical scores in the PTSD group, where we found state-related shame and PTSD symptom severity to be positively correlated with cerebellar lobule 9 and brainstem functional network connectivity, respectively. Together, these results suggest brainstem, midbrain, and cerebellar systems may not only be involved in the default mode network, but could be the systems contributing most profoundly to group differences. Given the role the default mode network has towards self-related processing, these results assist to explain self-related processing disturbances observed commonly in PTSD, such as midbrain-mediated viscerosensory urges to cringe, hide, or withdraw when recalling a shame-eliciting memory. In addition, these results provide a neurobiological basis to understand persistent shame, likely driven by midbrain-biased functional network connectivity in the default mode network. More broadly, we highlight the need to include brainstem, midbrain, and cerebellar systems into the intrinsic connectivity networks, since it seems these subcortical systems may hold the key to understanding how moral injuries and trauma alter self-related processing in PTSD.